You have hidden your winter grain inside a stone basin. It is everything your family cannot afford to lose. Then a storm comes. Rain slips beneath the covering. The grain swells. The water turns cloudy. A few days later, the surface begins to move. Tiny bubbles rise from nowhere. A sweet, sour smell fills the shelter. You should throw it away. Wet grain rots. Rotten food can kill. But someone tastes the liquid. At first, nothing happens. Then his face warms. He speaks louder. He laughs at people he normally avoids. He promises things he would never say while sober. Later, he stumbles, vomits, and sleeps so deeply that the others check whether he is still breathing. By morning, the grain is still ruined. But the liquid has done something no ordinary food can do. Now you face a problem more difficult than discovering it. How do you make it happen again? You do not know that single-celled fungi are eating the sugar. You cannot see the organisms. You do not know why one wet batch becomes intoxicating while another becomes sour, poisonous, or covered in mold. You have no thermometer, no clock, no written recipe. And every experiment costs food that might be needed during winter. This is the real puzzle behind the invention of alcohol. The first drink was probably not created by one genius following a plan. Fermented fruit, sap, honey, and grain can appear without human permission. Microbes were producing ethanol long before our species existed. Humans did not invent the molecule. We invented control. We learned how to take an invisible process, repeat it on purpose, and place it inside rituals, economies, religions, and relationships. That achievement would transform a spoiled meal into a feast, a plant into a social signal, and a dangerous poison into one of the most persistent technologies in human history. But the story begins millions of years before the first brewer touched a bowl. Long before humans stored grain, our ancestors were already encountering alcohol. Fruit does not remain fresh forever. Once its skin breaks, yeasts and other microorganisms gain access to the sugars inside. In low oxygen conditions, yeast can break those sugars down for energy, releasing carbon dioxide and ethanol. The fruit begins to ferment. For an animal searching for calories, that smell may carry useful information. It can lead toward ripe or overripe fruit rich in sugar. But it can also lead toward food that has begun to decay. The relationship is older than culture. In 2015, evolutionary biologist Matthew Carrigan and his colleagues published an unusual experiment. They did not excavate a drinking vessel. They reconstructed ancient enzymes. Using the genetic sequences of living primates, the team inferred versions of an enzyme called ADH4 from different points across roughly 70 million years of primate evolution. Then they produced those ancestral enzymes in the laboratory and tested how effectively each one processed ethanol. Most of the older versions performed poorly. Then around 10 million years ago, one mutation dramatically increased the enzyme's ability to metabolize ethanol. The change appeared near the period when the common ancestor of humans, chimpanzees, and gorillas was spending more time on the ground where fallen fruit is more likely to become heavily fermented. The study does not prove that ancient apes were seeking intoxication. It does show that dietary ethanol was important enough to leave a trace in the machinery of the body millions of years before deliberate brewing. Your liver did not meet alcohol in a tavern. It inherited a problem already faced by an ape searching for food beneath a tree. This changes the question. Humans did not suddenly discover an alien substance. We encountered a familiar chemical in a new form. Nature had already created the reaction. The challenge was learning how to separate it from random spoilage and make it happen when the group wanted it. Accidental fermentation could have happened almost anywhere humans found sugar. Crushed berries left in a skin bag, honey diluted by rainwater inside a hollow tree, palm sap collected for too long, cooked grain forgotten in a warm container. The first person to drink one of these mixtures did not need to understand chemistry. Taste, smell, bubbles, warmth, and altered behavior were enough to notice that something unusual had happened. But noticing is not inventing. A lucky batch is an event. A technology begins when people can reproduce the event. That required generations of observation. Which fruits worked? How much water should the vessel remain open or covered? Was warmth helpful? When did sweetness become strength? When did strength become rot? The answers were not written. They were stored in gestures, habits, seasons, tools, and the memories of people who had watched the process many times. The brewer may not have known what yeast was, but she could know that one old vessel started a new batch more reliably than a freshly cleaned one. She could know that a particular wooden paddle basket or clay jar seemed to carry the transformation with it. What looked like magic was actually microbial inheritance. Yeast colonies survived in cracks, fibers, dust, fruit skins, and brewing equipment. By reusing the same tools and environments, humans could select communities of microorganisms without knowing those communities existed. The process began to become dependable, and dependability changed everything. A random fermented fruit can intoxicate one person. A controlled batch can gather an entire community. To find the earliest known evidence of that transition, archaeologists had to look in a place where few people would expect to find the world's oldest brewery. They looked among the dead. Raqefet Cave lies on Mount Carmel in northern Israel. Between about 13700 and 11700 years ago, Natufian hunter-gatherers used part of the cave as a burial place. They laid people into graves, sometimes on beds of flowers, and returned to the cave for ceremonies connected with the dead. Carved into the limestone were deep mortars. For years, the stone containers were simply part of a larger archaeological puzzle about how Natufian people processed plants. Then Li Lu and her research team began examining residues trapped inside them. Lu was not searching for the origin of alcohol. She wanted to understand which plant foods people had prepared because direct evidence of prehistoric meals is often scarce. Under the microscope, the residue began telling a stranger story. The researchers found damaged starch granules and tiny mineral structures from plants called phytoliths. Some of the changes resembled what happens when cereal grains are germinated, crushed, heated, and fermented. But resemblance was not enough, so the team attempted to rebuild the process. They malted grains by allowing them to germinate. They dried and crushed them. They heated the mash. Then they allowed wild yeast to ferment it. At every stage, they recorded how the starch granules changed. The experimental damage began to match the ancient residue. Use wear on the mortars also resembled the pounding and crushing required to process grain. In 2018, Lu Jiajing Wang, Danny Rosenberg, Hao Zhao, Georgi Lengel, and Danny Nadel reported evidence from 3 mortars, indicating that the Natufians had brewed a cereal-based drink around 13,000 years ago. The residue suggested the use of at least 7 plant groups, including wild wheat or barley oats, legumes, and fibers such as flax. The beverage would not have resembled a clear, modern beer. It was probably closer to a sour, cloudy porridge or thin gruel, and it was produced before domesticated cereals became established in the Near East. No residue can replay an exact prehistoric recipe. Archaeologists have debated parts of the reconstruction, and a new discovery could always push the timeline further back. But the combined evidence from starch-damaged plant remains use-wear context. And experimental brewing makes deliberate fermentation the strongest explanation. The setting matters as much as the chemistry. These mortars were found at a cemetery. The oldest known evidence of cereal brewing did not come from a marketplace or palace. It came from a place where people gathered around their dead. That suggests the drink was not merely a way to rescue spoiled grain. It may have been prepared for ritual feasts, helping the living mourn, remember, and reaffirm the group around the bodies of those they had lost. Brewing grain is far more difficult than fermenting fruit. A grape already contains simple sugars that yeast can consume. A grain stores much of its energy as starch. Yeast cannot efficiently turn a hard kernel of starch directly into beer. The grain must first be persuaded to unlock itself. The Natufian process reconstructed at Raqefet likely involved 3 broad stages. First came malting. Grain was soaked and allowed to germinate. The seed began preparing to grow, producing enzymes that could break its stored starch into simpler sugars. The brewer then stopped that growth by drying the grain. Next came mashing. The malt was crushed, mixed with water, and heated. Temperature mattered even when no one could measure it numerically. Too little heat, and the starch remained trapped. Too much, and the useful enzymes could be damaged. Finally came fermentation. Wild yeast entered from the air plant's containers, tools, or an earlier batch. The microorganisms consumed sugar and produced ethanol and carbon dioxide. This was not one discovery. It was a chain of discoveries. Humans had to learn that a seed should be made to sprout and then prevented from becoming a plant. They had to learn that crushing and heating changed the liquid. They had to learn to wait while an invisible population transformed it. Every stage could fail. The grain might mold. The mixture might sour. The yeast might produce little alcohol. The vessel might become contaminated by organisms that made the drink unpleasant or dangerous. Successful brewing, therefore, required memory, timing, division of labor, and trust. It was a technology made from living things no one could see. And once people could control it, they faced another question. Why would a community deliberately sacrifice valuable grain to produce a drink that could weaken judgment, cause conflict, and leave the drinker unable to protect himself? The answer was not simply thirst. Turning grain into alcohol is costly. The process consumes time, fuel, water containers, and food that might otherwise be eaten directly. Intoxication also creates obvious dangers. A drunk hunter is slower. A drunk parent is less attentive. A drunk rival may become unpredictable. Large quantities can injure the body, produce dependence, or kill. Evolution does not make alcohol safe merely because humans have encountered it for a long time. So why did communities continue making it? Part of the answer may be nutritional and sensory. Fermentation changes flavor, texture, and digestibility. A thick fermented cereal drink could still function as food. Alcohol itself contains energy, although that energy comes with serious biological costs. But the location of the Raqefet mortars points toward a second answer. Alcohol could transform a gathering. A funeral feast asks individuals to contribute resources they could have kept for themselves. Producing a difficult beverage demonstrates preparation, generosity, and commitment. Sharing it creates a common experience at a moment when grief could pull people apart. A modern experiment offers one clue to the mechanism. In 2012, psychologist Michael Sayet and his colleagues brought 720 social drinkers into a laboratory and placed them into groups of 3 strangers. Some received a moderate alcoholic drink, while others received placebo or non-alcoholic beverages. The interactions were recorded in detail. The alcohol groups showed more behaviors associated with positive emotion, fewer negative expressions, more simultaneous smiling, and greater self-reported bonding. A modern laboratory cannot tell us why Natufian people brewed, but it demonstrates that alcohol can alter group formation, not just individual sensation. It lowers some social barriers. Conversation becomes easier. Laughter spreads. A temporary feeling of closeness can emerge between people who were strangers minutes earlier. The same disinhibition that creates warmth can also remove restraint. That is why drinking cultures rarely leave alcohol completely unregulated. Societies decide who may drink at what age, in which place, with which people, and during which rituals. Alcohol was never merely a beverage. It became a dangerous social technology, useful because it changed human relationships, and dangerous for exactly the same reason. Several thousand years after the Natufian brewers, another drink left its chemical shadow inside pottery at Jiahu, an early farming village in Henan Province, China. Jiahu was already an extraordinary sight. Archaeologists had uncovered early cultivated rice, carefully made bone flutes, burials, and carved symbols. Then Patrick McGovern and an international team began studying invisible residues absorbed into pottery jars dating to roughly 7,000 to 6,600 BCE. The jars appeared empty. But pottery is porous. Liquids can penetrate the walls of a vessel, leaving molecules trapped inside long after the drink itself evaporates. McGovern's team used several methods, including chromatography, mass spectrometry, infrared analysis, and stable isotope testing. Instead of searching for one perfect molecule labeled alcohol, they looked for a combination of chemical clues. The pattern pointed to rice. It also indicated beeswax, a marker connected with honey. And it suggested hawthorn, fruit, wild grape, or both. The drink did not fit neatly into modern categories. It was part rice beer, part honey mead, part fruit wine. That may be exactly how early experimentation worked. The first brewers were not trying to obey a legal definition separating beer from wine. They were combining whatever sources of sugar, starch, flavor, and microorganisms were available. The Jiahu drink reveals a new level of control. People were no longer waiting for one type of food to ferment by accident. They were assembling ingredients with different properties inside pottery designed to hold the reaction. A grain could provide starch. Honey could provide concentrated sugar. Fruit could provide sugar, acidity, flavor, and microorganisms on its skin. The vessel allowed them to bring these elements together and wait. This was recipe thinking. The drink existed first in the brewer's mind, as a sequence gather crush mix. Seal, wait, open. And because recipes can be remembered and taught, fermentation could travel through generations. A jar of liquid became a container for accumulated human knowledge. Fruit fermentation offered an easier path than grain. Crush ripe grapes and the juice already contains sugar. Yeasts living on the fruit and in the surrounding environment can begin the transformation with little human assistance. But dependable wine still requires control. The fruit must be gathered at the right time. The juice needs a container. Air exposure, temperature, cleanliness, and storage all shape the result. At the Neolithic settlements of Gadatrili Gora and Shulaveris Gora in what is now Georgia, archaeologists uncovered pottery dating to approximately 6,000 to 5,800 BCE. Some of the large jars had been embedded directly into the earthen floors of buildings. The fragments did not contain visible wine. Patrick McGovern and an international team had to search for a chemical memory. They analyzed residues from multiple jars and found high levels of tartaric acid and related compounds. In that region, tartaric acid is a strong marker for grape and grape wine. The chemical evidence was supported by pollen grape, remains climate reconstruction, and the presence of wild Eurasian grapevines. One jar had small clay decorations around its rim that may have represented clusters of grapes. Whether that interpretation is correct or not, the scale of the containers is clear. These people were not simply eating a handful of fruit. They were collecting enough grapes to fill large vessels, crushing them, allowing the juice to ferment and storing the result inside settled households. The jar changed wine from a brief accident into a seasonal resource. Harvest could be concentrated into liquid. The liquid could survive after the grapes disappeared from the vines. And a family or community could open the vessel at a chosen moment. That control created new forms of power. The person who owned the jar could decide when the drink appeared. The host could turn stored fruit into generosity, obligation, celebration, or status. Alcohol was becoming more than a shared altered state. It was becoming property. As villages grew into cities, alcohol moved from the ritual bowl into administration. Brewing required grain, water, fuel vessels, skilled labor, and storage. Whoever controlled those resources could control production. In Mesopotamia, beer entered the written record not merely as a pleasure, but as an allocated resource. A clay tablet from Umma dated to about 2028 BCE records rations of beer, bread, oil, and onions for messengers. The entire record fits onto a piece of clay only about 3 centimeters wide. That tiny tablet captures an enormous transformation. The drink had become countable. A messenger could receive beer as part of an institutional ration. Temples and palaces could track how much was produced, who received it, and when. Other tablets list beer rations, malt, barley, and deliveries. At Raqefet, the drink may have helped a small community gather around the dead. In the city, alcohol could connect strangers who were linked not by kinship, but by bureaucracy. The brewer became a specialist. The recipe became an asset. The jar became inventory. The ration became compensation. And the institution that distributed the drink could turn biological desire into social control. Alcohol could reward labor, honor guests, feed ceremonies, and mark rank. The same substance might be sacred in one setting, ordinary food in another, and evidence of excess in a third. This flexibility explains part of its persistence. Alcohol does not have one human meaning. It borrows meaning from the social structure around it. A shared cup can communicate equality. A rare wine can communicate hierarchy. Refusing a drink can signal distrust. Offering one can begin an alliance. Controlling the supply can create dependence. Once fermentation became reliable, societies did not merely consume alcohol. They built rules, occupations, taxes, rituals, and identities around it. The invisible work of yeast had become visible human power. Alcohol acts on the brain, but people rarely experience it in isolation from expectation. The same chemical can produce different behavior in a funeral, a wedding, a military camp, a family meal, or a crowded tavern. Humans learn what drinking is supposed to mean. They learn whether intoxication, excuses, aggression, permits, emotional honesty, demonstrates adulthood, insults the host, or opens communication with ancestors. Biology changes inhibition. Culture supplies the script. This interaction helps explain why alcohol became so deeply embedded in human societies. It creates a temporary version of the group. People speak more freely. Status boundaries may soften. Songs become louder. Grief becomes public. Promises feel easier to make. But the temporary group is unstable. Judgment declines before confidence does. A person may feel more capable at exactly the moment coordination and self-control are weakening. The drink can build trust that would not exist while sober. It can also produce commitments no one intended to keep. This contradiction may be the reason alcohol is so often surrounded by ritual. A ritual places boundaries around the altered state. It determines the vessel, the order of serving, the words spoken, the people present, and the moment when drinking must stop. The rules do not remove the danger. They make the danger socially usable. For prehistoric communities that could matter during moments requiring unusual cooperation, funerals, seasonal gatherings, alliance building, courtship exchange, or collective labor, alcohol could make a group feel unified, before it truly was. Sometimes that feeling may have helped people cooperate. Sometimes it may have hidden conflict until restraint disappeared. The invention was therefore not simply fermentation. It was the cultural container built around fermentation. Humans created ceremonies strong enough to hold a chemical that weakens the individual boundaries on which ordinary social life depends. There is a final clue hidden inside the word itself. The English word alcohol did not originally mean beer, wine, or spirits. It came through medieval Latin and Spanish from the Arabic al-kuhul, referring to kohl, a finely powdered antimony cosmetic used around the eyes. The connection seems absurd. How did a black powder become the name of an intoxicating liquid? The bridge was refinement. European alchemists used forms of the word for substances reduced to an extremely fine or purified essence. As distillation techniques developed, alcohol could refer to the distilled essence of a material. Only later did the word narrow toward the intoxicating spirit extracted from wine and other fermented liquids. The history of the word repeats the history of the technology. At first, humans did not isolate ethanol. They produced complex fermented foods containing water, acids, sugars, plant compounds, microorganisms, and relatively modest concentrations of alcohol. Distillation came much later. Heating a fermented liquid allows compounds with different boiling behaviors to be separated and concentrated. The result transforms the risk. Fermentation is limited by the tolerance of the microorganisms producing the ethanol. Distillation can push far beyond that biological ceiling. The drink becomes smaller, stronger, more portable, and easier to trade. It also becomes easier to consume a dangerous dose quickly. This is an important distinction. Humans learned to brew in prehistory. They learned to concentrate alcohol through sophisticated distillation in historical societies. The molecule remained the same, but concentration changed its power. And the word we now use for every beer, wine, and spirit began not in a drinking cup, but beside the human eye, as the name of a powder made extraordinarily fine. Return to the wet grain. The surface is bubbling. The smell is sweet and strange. You still cannot see the organism responsible. But now you understand what the invention required. It required an animal already equipped to encounter ethanol long before it became human. It required people willing to notice that one spoiled food produced a repeatable effect. It required someone to remember the vessel, the season, the temperature, and the waiting. It required grain to be germinated, crushed, heated, and exposed to the right invisible community. It required containers that could hold the reaction. And it required rituals capable of controlling what happened when the drink entered the group. No single person invented alcohol. Yeast had been producing it for millions of years. Humans invented a partnership with yeast. We supplied concentrated sugar, protected environments, tools, and time. The microbes performed the chemistry. We then gave the result meanings the microbes could never understand: mourning, celebration, courage, hospitality, status, payment, rebellion, escape. The oldest known evidence of cereal brewing comes from stone mortars in a burial cave. That may be the most revealing detail in the entire story. The first known brewers were not merely trying to become drunk. They were making something for a gathering around the dead. Before alcohol became a product, it may already have been a bridge between individuals, between generations, and between the living and those they refused to forget. That bridge was never safe. The same drink that softens fear can remove judgment. The same ritual that creates belonging can create pressure. The same technology that preserves a harvest can destroy a life. But danger did not prevent the invention from spreading. It made control more valuable. So how did humans invent alcohol? We did not create the chemical. We learned to recognize an ancient microbial process, repeat it deliberately, and place rules around its effects. Nature made ethanol. Humans made the occasion. And the true invention was not the drink inside the vessel. It was the invisible agreement among everyone around it about what that drink was allowed to mean.